Hello everyone. Now I'm going to show you how to find the gradient of a point on a curve. Let's use this example. Find the gradient at the point on this curve where x equals to 5. So, where exactly is this point on the curve where the x is 5? Okay, if you look carefully, it's actually, okay, the 5 is there. So the point on the curve that has x equals to 5 is this point. So we want to find the gradient of this point on the curve. So how do we do that? Step 1, you need to draw a line that passes through this point only. And this line cannot touch any other points on the curve. Okay? So I'll give you 5 seconds to absorb this definition. Okay, let me show you some examples. Can this line be the line that I want? Does it pass through that point? And does it not pass through any other points? The answer is no, because this line touches another point on the curve. We do not want the line to touch any other point on the curve except that point that we want. How about this? Is this the line that we want? The answer is no, because the line cuts the curve at the red point on the left. So this is not the line that we are looking for. How about this? If you look on the screen, yes, the blue line touches the curve at one point only. However, if we were to go somewhere up there on the top left, the blue line and the curve will touch each other. So we cannot accept such a line. So how do we draw a line that we want? The answer is this line. Now observe this line carefully. This line passes through the point on the curve that we want, and it does not touch any other point on the curve. This is the line that we want. If we were to zoom on the previous picture, you will notice that the line that we draw touches the point exactly, and it does not touch any other point on the curve. Now, how to know whether the line that we draw is okay, is what we want? Okay, observe the screen carefully. One way to check is to look on one side of the point. For example, here. Make sure this region and this region are about the same. Okay, the space of the one on the right and the space on the one on the left are almost the same. That's how we check whether the line that we draw is okay. Now, step 2. After we have drawn this line, we find another point on this line that is easy to read. What do I mean by easy to read? Okay, for example, okay, I must choose a point on this line. So, if I choose this point, is that point easy to read? Now, what is the x coordinate of that point? If you were to look carefully, okay, we can't tell for sure. We can't tell whether it's 1.7 or 1.8 or 1.9. Okay, and how about the y value? Once again, we can't tell for sure whether it's 2.7 or 2.8. So, when you can't tell for sure whether that line, whether the x coordinate or the y coordinate of that line you can read for sure, then do not choose that point. What I meant by easy to read is such that, hold on. What I meant by a point that's easy to read is, for example, like this. this point, the x-coordinate is easy to read. We know it's 1. And the y-coordinate, it's -4. That's what I meant by a point that's easy to read. I do not need to estimate the x-coordinate or the y-coordinate. So this is one such point that we choose. You can choose any other point on the curve, okay? It doesn't matter, as long as you can read the x-coordinate and the y-coordinate easily without the need to estimate. So, step 3. Once I have identified the point on this line, I use these 2 points to calculate the gradient of the line. Okay, recall how we find gradient? Okay, before that, okay, we need to find x1, y1, x2, y2. So for this point, okay, we need to know x1, y1. Okay, if you read carefully, x1 is 5 and the y1 is 2. As for this point, x2, y2. Okay, the x2 is 1. The y2 is -4. So once you have this, apply the formula for gradient, which is y2 minus y1. So -4 minus 2, be careful on negative, over x2 minus x1, 1 minus 5. And the gradient of the line is 3/2. Okay, so why are we finding the gradient of the line while we were trying to find the gradient of the point on the curve? Now, this is the most important part of this section. The gradient of the point on the curve where x equals to 5 is the same as the gradient of this line. I repeat, the gradient of the curve at that point is the same as the gradient of this line. Therefore, the gradient of the curve at that point that we have been trying to find is 3/2. So let's summarize. When you are given a curve, okay, most of the time you will draw the curve first, and you are asked to find the gradient of this curve at a particular point. For example, the point here, and you want to find the gradient at this point. The first thing you do is draw the line. Make sure the line only touches that point on the curve. It must not touch any other point on the curve. But how to know for sure whether this is the correct line? Look at the green region that I shaded here. Make sure that there is equal spacing on both sides of the point. After you have done this, find another point on the curve that is easy to read, where you do not need to approximate the x and the y coordinate of this point. Once we have done that, we find the gradient of this line. So we need x1, y1 of one point and x2, y2 of the other point. Put it inside the formula and then you get a value. And the important part is the gradient of the point on the curve is the same as the gradient of that line. Now this line that we have been talking about, it has a special name. Its name is simply the tangent line.